Hello. How's everyone doing today? Doing well? Good? Good. It's so nice being here. This is the third day of presentations I've done here at GIDS, and this is one of my favorite conferences to do. My name is Scott Davis. I run a software consultancy back in the States called Thirsty Head. I started my life out as a Microsoft developer, but then very quickly moved over to Java. My first book with O'Reilly was called JBoss at Work, but then I discovered Groovy. And have spent a lot of my professional career dealing with Groovy and Grails, the web framework. Quick show of hands, how many of you are Groovy developers in here? Oh, not nearly enough. It's wonderful that you're here. That means that the rest of you are not using Groovy at all. How many of you are brand new to Groovy, never seen it before in your life? Very good. That's what I love to see. New recruits, yeah? Because as a Java developer, what we're determining is that Java is not the only language that you should know. Neil has popularized a phrase called becoming a polyglot programmer. Polyglot, of course, is Latin for many glots. No, that's a joke. It's not for many glots, it's for many languages. And it's all about using the right language for the job, using the right tool for the job. Because Java is a platform as well as a language, what you end up with are many different languages that can share a common platform. So in this last talk, Neil was spending a lot of time talking about Scala. Scala is a language that compiles down to bytecode. Java compiles down to bytecode, so you can run those two side by side. He mentioned Clojure. Clojure is a Lisp-like language that compiles down to bytecode, so you can run it side by side with Java. Well, Groovy is a language that compiles down to bytecode as well. But I like saying if you're already a Ruby developer with an R, you'd probably like JRuby, which is a Ruby runtime that runs on the JVM. It allows you to take your Ruby code and run it unchanged on the JVM. If you're already a Python developer, you might really enjoy Jython, which allows you to take your Python code and run it unchanged on the JVM. If you're a Java developer, I think you'll really enjoy Groovy a lot. Because Groovy is targeting all of us. Groovy is targeting us as Java developers. If you want a really geeky example of what Groovy is all about, it starts with the Java AST. The Java AST is the abstract syntax tree. It starts with all of the Java keywords, all of the language, all the syntax rules, and then it builds on top of it. So Groovy is a perfect superset of Java. It allows you to do everything you can do in Java and then some. So much so that you can take any .java file and rename it to .groovy and it will run unchanged. That gives you an idea of how deep the two languages share with each other, how much they share with each other. You can't take a .rb file and rename it to .java and expect it to run. You can't take a .py file and convert it to Java and expect it to run. But you can take a .java file and convert it to Groovy and have it run. So what I'm going to be talking about here today is not just Groovy in general, but specifically using Groovy to deal with XML files. How many of you deal with XML on a regular basis? Yeah, everyone's hands goes up. Yeah, there are a lot of different Java libraries out there that you can use, but maybe what you might consider using is Groovy for your XML needs. Since we're in a polyglot land, you can leave the rest of your app alone and just do your XML manipulation in Groovy. But before we get into Groovy, we need to talk a little bit more about XML, don't we? Have you heard this joke? That XML is like violence? If it's not solving your problem, you're just not using enough of it? Yeah. Yeah, sometimes when we come up with a brand new idea, it feels like every problem can be solved with that. Doesn't it seem like XML has been around since the beginning of time? In fact, it's just been around since about 1996. So it's really a fairly new technology, all things considered. Now what's interesting is that XML came around the same time that Java did. And so when you had Java, this brand new language, and XML, this brand new language format, what you find is that these two kind of grew up together, and we think of them in the same way. It's hard to imagine being a Java developer without touching XML. How would you build your project without a build.xml file? How would you deploy your project without a web.xml file? XML is everywhere in the Java space. And so what we really need is a good tool to help us deal with XML. Are you familiar with the 5 stages of grief? Yeah? Well, the 5 stages of XML are very, very similar. So let's go through this together. When you're starting a brand new project, you start in the denial phase, don't you? You say, XML is going to solve all of my problems. Yes, because XML is non-language specific, you're saying, this is wonderful. I'll get XML from over here and I'll be able to use it. It doesn't matter where that XML is coming from. This is going to solve all of our problems, isn't it? And then you come to realize that XML doesn't solve all your problems. How many of you have tried to deal with a SOAP call from a Microsoft provider in a Java client? It's enough to make you pull out your hair, isn't it? You say, wait a second, SOAP is a standard, isn't it? But we've got the Microsoft version of the standard, and then the JBoss version of the standard, and then this version, and that version, and the other. And so we're in the anger phase right now. So what do we do as good Java developers? We bargain. And how do you bargain in Java? You just add another layer of abstraction. There's no problem in Java that can't be solved by adding another layer of abstraction in between you and the core problem. So you start throwing jars in your directory, you start adding new libraries, eventually you can completely insulate your way from the problem. Or can you? No, you really can't. And what's interesting about Java is most of the time we try to move the problem farther and farther away from us. What you're going to see here in Groovy is it actually brings the problem closer at hand. It's going to feel like we are dealing with the raw XML. And that's not a bug. It's a feature. It's a benefit, because the closer you get to the problem, the easier it is to manipulate it, the easier it is to work through these kinds of things. And then, and only then, can we get to the final stage of XML, acceptance. XML isn't going away anytime soon. What you need is the right set of tools to deal with it. Because if you have the wrong set of tools, it feels like you're in a prison, ironically, of your own making, isn't it? We'll build up this complicated XML structure. Oh, wait, now we have to parse this complicated XML structure? Who thought that was a good idea? Yeah? But what that means is you just haven't been using the right tools. So this brings us to the Groovy XML Ninja part of the presentation. What we're going to do is we're going to start by parsing not even XML. We're going to start by parsing plain old text files. And then we'll step up to parsing CSV files, comma-separated value files. And then we'll begin parsing XML files. It's interesting because Groovy ships with 2 libraries standard. We can either use an XmlParser or we can use an XmlSlurper. Slurper is my favorite, and not just because of the name. Because Slurper actually gets you close as possible to your base XML. But we'll give examples of both, so you can see what's going on with XmlParser and XmlSlurper. And then we'll do the other end. Once we've read in this XML, we'll begin writing it back out. And not ironically and not surprisingly, there are two different ways we can do that. We can do it with a simple markup builder, which is synchronous, which writes it out immediately. Or we can deal with streaming markup builder, which allows you to build a portion of your XML document and then bundle it all together and stream it all out at once. So this is what we have to look forward to in the next 50 minutes or so. Are you ready to dive in? Yeah? All right, good. Enough of these silly slides. Let's do some live coding. So, to begin with, there we go. I wanted to show you, we're in a nice empty directory, nothing up my sleeve. We're going to start from the very beginning. The only thing you'll see in there is Twitter. A lot of times I like doing some live Twitter calls, and the internet gods have been very angry with me all week. And so I am just hedging my bets right now. All I did here was I did a query. Let's see. All I did was a query to give us some raw XML. Now, we'll certainly come in here and parse it out and do more fun things with it. But we got a lot of work to do before we start with XML. Let's do this. Let's start with a simple file called names. And I'll start plugging some names in here. My good friend Neil Ford. My good friend Venkat. We don't actually have enough time to type in Venkat's last name. We only have 60 minutes. It's a very long name. Oh, okay, we'll type it in. All right, Subram. I got cramp. Hold on. All right, here we go. I am. There we go. All right, so that's his last name. And then we can put in mine as well. He knows that I say this about him behind his back. You can tell him, but he already knows. So we got a list of names here right now. And what we want to do next is we want to be able to read this file in. And so what we'll do is something like this. Now, when you see me do something like this, def f equals new file, what I want you to realize is that file that I'm dealing with. Do one thing real quickly here. That file is a Java IO file. Even though we don't say file f equals new file, and we don't say import Java IO file in here, this is still truly a file, a Java file. So I can do a lot of interesting things with that file. One of the things I could do is I could just print out the text of it. So one of the things I could do is I could say, all right, just print out the text. But what I'm interested in is doing a little bit more than just that. What I'm interested in is maybe being able to walk through it line by line. So being able to do something like f dot each line, println it. Now, it may not look a lot different, but if I do something like this, if I say, you begin seeing that I am walking through this line by line and dealing with it. Isn't this kind of the best of both worlds? The fact that I have a Java file with all of the methods available to it, but I also have these nice groovy features that allow me to go in and walk through a file, I don't know, each line at a time. So, well, walking through a plain old text file is all fine and good. What if I wanted to do something like this? What if I wanted to create a names.csv? And I wanted to do something like this. We can see now I've separated those values with a comma. And so maybe what I should do is this. Names.csv. Rather than doing an each line like I did before, maybe what I want to do is a split each line. And what I'll do is I'll split based on that comma. So if I were to do something like this now, let me do that. That'll make it a little bit clearer. What I should see now is just the first name come out. Comma. There we go. And if of course I wanted to get the last name out, yeah? So we begin, yeah, you have a question, please.
Like, as we have parsed and printed the individual lines, so can we directly convert that CSV file into Java object as we do for XML marking and marking kind of thing?
This is a very good question. The question is, can we turn around and take this CSV file and marshal it into an actual object? You absolutely could. So let me show you what we could do in just the simplest possible way. I can come in here right now, and I could say I'm going to create a person. And that person has a first name and a last name. And just for grins, I'll give us a toString method so we can see what it looks like. And what I'll do is I will return Groovy supports something called string interpolation. So that means that I can use these variables right in the middle of the string rather than having to say this plus that plus that plus that plus that. I can just kind of use it all at once. So what I've done is I've defined a class here. And maybe what I want to do in here is I want to say def p equals new person, p.first equals part sub 0, p.last equals part sub 1. Yeah? And so what we end up with then is having this person in here. And what I can really do is I can say does that answer your question? Yeah.
Yeah, like, but little different from this one, like here we are programmatically doing this. So, like we are having framework like GATK or something there for a grammar definition, they convert a particular file into object. So can we have that kind of?
So your question, once again, is a very good one. And this is what I alluded to earlier, that so many times what we're looking for putting layers of abstraction in between us. And I will tell you, some of these libraries like Hibernate are really wonderful, that you don't have to take the relational database set and convert it into your object yourself. In this talk, what I'm trying to do is get closer to the problem and show you how easy it is to reach out of those kinds of things and do it. So the things I'm going to show you here don't come in at that higher level of abstraction. What I'm trying to do is show you how to do those low-level things so you could turn around and build a tool that does it on your own. Fair enough? You're asking a very good question, but what I'm trying to do is get us closer to the data to give us the control, make sure we have the fine-grained control over those things. Excellent. All right. Well, we still haven't gotten into XML yet, have we? So maybe it's time to do that. Maybe it's time for us to come in here and create a names.xml. And so what that gives me the ability to do is come in and say, all right, here are these names. I'll start with a person who has a first name of Neil and a last name of Ford. Once again, a first name of Venkat, last name of Subramanian. So what I have now is an XML file. Can I each line through this? Well, I could, but now all of a sudden my data is spread across multiple lines. So I can't just do an each line like I was doing here. And I really can't even do a split each line, because what I'm left looking at here is an object that's spread across multiple lines. What we really need to do is we need to parse this thing up. We can't do it on a simple line by line or token by token basis. So what I need to be able to do is I need to be able to parse this. And so the first class we will use is an XmlParser. Yeah, works out nicely. So I'm going to do the same thing I've done all this time. Come in here and open up, this time I'm going to open up names.xml. Only this time I'm going to do something else. Notice that we start with a root element of names. Let me come in here and let me say def names equals new . Let me stretch this out a little bit more so we can try to see everything at once here. So what I'm doing is I'm opening up that file, but then I'm immediately handing it off to a Groovy XML parser. And what that's going to do in that one it doesn't like that, huh? Did I get the package wrong? All right. It doesn't like Groovy XML parser. Really? Really now? All right. Now that's how we're going to play this game. Okay. So, Groovy XML parser. It's in Groovy util XML parser. Well, of course it is. What else would it be in? There we go. Now, nothing could possibly go wrong. Do you want to bet? There we go. Now, that's not much to look at. But what I want you to realize is what this has done is it's taken that XML document and it's converted it into an array of nodes. And each one of those nodes, in turn, has a hash map of attributes. So this is getting closer to your question right here, is that I've taken XML and I have transformed it, but I haven't transformed it into an actual object. What I've done is I've simply transformed it into an array of elements and a hash map of attributes. But now that I have this, I can start doing some very interesting things. One of the things I can do is I could say names.each. But in fact, rather than each lining my way through it, I am going to say names.person.each. And so now, and what I can do to make this a little bit easier to read here is I can put a separator in there. I'm just taking a simple string and multiplying it by 25, giving myself a nice little separator in there so we can see what's going on. We can see now that by eaching my way through, I have managed to each my way through each element. But rather than doing it in a generic way like get children and children.each, what I've really managed to do here is I've managed to refer to those elements by name. One of the things Venkat is going to talk about later this afternoon is this notion of using Groovy for DSLs, domain-specific languages. When I'm talking about getting closer to the XML instead of farther away, what I'm saying I don't want to do is treat this as a generic document. Document D equals new document. Get root element dot get children. Each children do something like that. I don't want to do this in a generic way. I want to get closer to the data and feel like I'm manipulating it directly. So when I'm saying names.person.each, and when I'm saying something like println it.first.text, what I'm actually able to do here, scoot this over so you can see it. That's better, isn't it? What we're dealing with here now is we're dealing with being able to go in and touch the individual elements by name, which makes this code not only a joy to write, but it makes it a joy to maintain as well, because I can look in there now and I can see exactly what's going on. Now, it is the default variable when you're inside of a closure. Each is a closure. A closure is nothing more than an executable block. It's a hunk of executable code. Venkat's going to talk about closures in the very last slot today. Groovy closures for fun and profit. And so this it variable name is simply because I hadn't named the variable. If I were to come in here right now and say, yeah, person, then what I end up looking like is names.person.each, person.first.text, or person.last.text. What I'm doing here now is I am actually grabbing those elements. Yes, sir. Do go ahead in your back-to-back. I'll take the closer gentleman first in the purple shirt. Yeah.
My question is, there are some API that allows to parse large XML files, but because sometimes...
You're right. This is actually doing DOM manipulation, which means it's reading the entire document into memory and then traversing the node tree that way. How would you deal with a very large XML document in a more event-driven way, not in Groovy, but in Java? What would you end up reaching for?
We would use cyclic
Sacks or stacks are two options in there as well. And one of the things you can do with this is you can actually point it to a Sacks parser instead of doing DOM manipulation stuff. So when you're dealing with Sacks, you're going to be dealing more in an event-driven way. You're going to be listening on certain nodes. The syntax is going to change, but you do have the capability of doing those kinds of things. So it's a very good question. I would definitely reach for Sacks or stacks. S-T-A-X is a more modern way to accomplish the same thing. Yeah. You get a question as well.
So what if the person has an attribute called each? So right now we're calling the each method on every list. What if a person had an attribute called each? What would
I am so glad you asked. How do we deal with attributes? Let's find out. Let's go back to our names, and let's just say arbitrarily that each one of these people come from a different city. Neil comes from Atlanta. Venkat comes from Broomfield. Yeah? Well, what that's going to end up looking like is instead of printing out the person's text, we can get the person's attribute and grab that. So what this means now is when I'm printing out this information, I can print out the person's first name, the person's last name, and then person .attribute.city. And I can get the things that way. Okay. Yes.
So you did names.person, and since there was no method called person, it figured out that it's probably an attribute of child called person. So what if I had a child called each? Would it become the closure which gets called, or would it go into the...
Now I understand. So your question is, right now we're going name.person, and you correctly identified what Groovy is doing. Groovy allows you to make method calls that don't exist. There is no getPerson method on that name object, so it just assumes that there's an element named person in order to do that. When you said, hey, I'm trying to each my way through, what would I do there? Well, you probably wouldn't want to name it that way. But if you did, there are some things you could do. You could do a slightly alternate syntax. Rather than doing kind of a person.last or a person like this, we could come in and get at that element this way, using a more hash mappy kind of notation. And what that will bring to the party then is a really clear way of making sure that you don't think that's a method call, that that truly is a child element that you're trying to get at. Outstanding question. So, we can certainly do a lot more with XmlParser. Well, I'm trying to comment this out and it's not letting me. All right. There we go. There's more than one way to skin a cat. You can do more generic ways of programming. If I were to turn around right now and println names .attributes, that's a way that I can just generically get at that. It's saying that's an empty hash map. There isn't a set of attributes on names. So if we were to come in right now and add a series of attributes to names, we might say that the source is coming from CouchDB and it's updated on 2013 0515, right? Something along these lines. Once we have those attributes in there, being able to come in and get your hands on those make it very easy. And then once you do something like that, we can turn around and not just get at the attributes, but we could say name.attributes.source and just get that value. So you do want to use the default names whenever you can, but you can also use the more generic kind of attributes and be able to get at it that way. So while this is all fine and good, I got to tell you that having to type in text is kind of bumming me out. Having to type in attribute like this is kind of bumming me out. It's not that that's a bad thing by any stretch, but what the XmlParser forces us to do is think of that XML document as if it were a list or as if it were a hash map, because in fact that's what it is. But it forces us to make method calls. And my whole goal here is to feel like I am touching the XML directly. And so while this is getting me fairly close, I do feel like there's a little bit of an API in between me and the raw data. So let's turn around and slurp this XML in instead. So I'm going to do the same thing that I've done all this time, names.xml. I'm going to say def names equals new Groovy util right? So I'm doing everything that I did before with one exception. This time I'm using a slurper instead of a parser. So what changes? Names.person. That hasn't changed at all. But what has changed is now I can say person.first. I can say person.last. And I can get at the attribute that way. Have you done any XML xquery? It kind of looks like it, doesn't it? Except we don't call it xquery, of course. We call it gpath. Instead of xpath, we call it gpath because we're in Groovy. We're kind of funny that way. But what we can do now when I am slurping in that Groovy, you can see that I'm able to get at that information. But once again, I feel like I am right there dealing with the data directly. Yeah? That is when it gets a lot of fun. That is when it gets a lot of fun, being able to come in and do this. And this is why I prefer Slurper over Parser, because it really makes me feel like I am dealing with the XML directly. There is zero impedance mismatch. There aren't any method calls or anything like that. It feels like I'm reaching out and touching the elements directly. What questions do you have about parsing XML or slurping XML? Yes?
How does it internally read the file and load the data? Is it again completely in memory like
parser in terms of DOM versus SAX? And the answer is no. They're both DOM manipulations. So both slurper and parser, as we're talking about right here, are reading the entire document in. So you would still use SAX or stacks to do that. That's going to complicate this code because you need to start having callbacks and doing a lot of things like that. So what I'm trying to show you are the easy cases of doing these things. And many times when you're making API calls, the document that's going to come back is going to be more than appropriate to use parser or slurper. At Time Warner Cable, we would slurp in a day's worth of television programming. That was roughly 200 channels across a 2-hour block. We would use this kind of stuff all the time and not even bat an eye about it. The only time you really need to get concerned about the size of your file, if it is literally megabytes or literally tens of thousands of elements. That's when you would really need to be concerned about these kinds of things. But I think you'd be surprised at how far you can run with this if your data sets typically are of a reasonable size. Now, you know what my answer is going to be if you said, well, my data set isn't a reasonable size. Break it up, right? Break it up and make it a reasonable size and continue to use these kinds of things. Your next question was, it looks like Slurper was implemented as a DSL. Absolutely. This is what we mean by a DSL. It makes it feel like that. And rather than demonstrate how to build a DSL, I'm going to defer to my good friend Venkat, who's going to demonstrate it at the end of the day. Because he's going to give you a full hour on this. What I need to do in the last 15 or minutes so we have together is turn around and talk about how we can build XML. Because this is only half of the story. Being able to slurp in or parse in XML is one thing you want to do. The other thing we want to do is we want to be able to generate XML. So let's turn around now and give myself a little bit more room. So we can come in and begin generating XML. So what I'm going to do is this. I'm going to start with names once again. But this time what I'm going to do is I'm going to make it a new Groovy XML MarkupBuilder. Now this is once again getting to that DSL notion. When I am saying person.name.first, those are all methods that don't exist. And so parser and slurper are expecting them to be elements. We're going to do the same thing here, except I am going to be generating the XML. But the same rules are going to apply, that if Groovy doesn't recognize that as a method call, it's going to say, oh, you must mean you want a new element. So if I say names, and then I say person, and then I say first, what I'm doing is I am actually building that up. And getting it out on the other end. What's interesting is I'm getting a call. That doesn't look right. To make that equal. No, that wasn't it, was it? What did I screw up this time? Ah, it's a dot. There we go. All right. And now, did I say now? I meant now is what I meant. There we go. There we go. And so we can see how easy it is to turn around and build up the opposite direction as well. If I wanted to turn around let me do this. There we go. I'll close that up. So as we're building this structure up, we begin seeing how easy it is to spit out XML in the other direction. The same rule for attributes applies. So person right now doesn't have any attributes on him. But if I wanted to, I could say Venkat is from Broomfield. I can say Neil is from Atlanta. And it starts building things out the right way. And all I need to do is continue with a comma delimited list, and that will turn around and give you all of those attributes in a well-formed way. So you can imagine now how we would begin combining these things, being able to parse in one document, go in and make some changes, and write them out in the other direction. Now we can do that, but there are a couple more things with this markup builder that I want to do before we move on. One of them is, you'll notice this is just going right out to system out println. What we might want to do instead is capture it. So if I were to do something like this, what that's going to do now, by passing that string writer in, that is going to turn around and capture that output. And just so we can see, I can say println starting the XML generation. And then ending the XML generation. What we're going to see here is we don't get that output anymore. It's hanging out in that string. So one of the things we could do is we could simply print it out like we did before. Get this up so you can see it. Remember, that's our string writer right up there, and so I could just turn around and print that thing out. But what we probably want to do is something a little bit more interesting. What we probably want to do remember how we use .text to read it in? The very first thing? Well, we can use .text to write it out as well. Which now means I've run and I've got output.xml. So none of this is very hard. And as a matter of fact, that's what you want XML generation to be. You really do want it to be as trivial as this so you can write those things out without thinking about it. You can read them in without thinking about it. Now, this strategy right here worked nicely because I wrote the entire XML document at once. What I might want to do is something like this. And as Venkat's talking about closures for fun and profit, this is what he's talking about. Person 1, once again, is a closure. And so being able to build up that closure and just have it hanging out in memory, not doing anything at all. And then later on, I've got a person list, and I'm turning around and writing person 1 to that list. And so you could see how you could begin building these things up. If we had a database, you could see how you might be reading information in from a database and then generating XML out. But you don't want to wait until you've been through every single one of the records. You do want to defer until you've been through every single one of those records, because the JDBC results set isn't going to load everything into memory at once. And so we need a markup builder that isn't going to try to do all that synchronously as well. And so if you have a JDBC results set that is building up these things, you can write them, and then when you call builder.bind, that is what would assemble all that stuff together and write it out all at once. So once again, just to show you this in action, that is a streaming markup builder. So here's what we'll do now. We'll say XML equals new Groovy XML streaming markup builder. And I can bring up anything that I want at this point. You can see just building up this person in here uses exactly the same syntax we did before. Person who has a city of Broomfield, who has a first name of Scott. This is not a valid method name. Groovy would think you're trying to subtract list from person, and we don't want that. One of the things Groovy is extraordinarily good at is sometimes doing not what you would expect it to. If I had a message like this, it can't possibly be right, can we? If I do something like this, that's getting closer to the truth, right? Scott is something. I don't know what it is. It isn't cool, but it is something. So we can see that this subtraction, we're actually doing, what's the opposite of string concatenation? Right? String arithmetic, on this, trying to do, slicing these kinds of things out. So what we don't want to do is inadvertently try to subtract list from person, whatever that means, so we can turn around and surround those in quotes. Now this out is a magic variable that comes along with the streaming markup builder, so that out is what is going to allow me to write the person one closure to the content of that list. So when we come back here and now we say def list equals person list And then do you remember what we have to do to finish this deal up? We need to bind the person list. Builder.bind list. And now That's because I didn't name it Builder. It's amazing how that works, huh? There we go. And what we would need to do, did I not print it out? All right, my goodness. There, and we get the output out of it. Another thing you probably noticed is that the markup builder gives you pretty printing, and the streaming markup builder doesn't. But there is a way that you can turn pretty printing back on when it comes to streaming markup builder as well. So we've covered a lot of ground here. But at the end of the day, what we've managed to do is use Groovy not to insulate us from that core XML, but actually bring us closer to that XML. And all these things I focused on here, we're just dealing with XML. Groovy also has a JSON slurper. So all of these same tricks that we did in XML would work for JSON. Groovy offers a config slurper that allows you to read in .properties files. Any standard Java properties files can be read in and navigated this way as well. So what's really nice about Groovy as well is that once you learn one way of doing something, there are many times similar libraries that do the same kinds of things. So we covered a lot of good ground here. But do you feel like you are one step closer to being an XML ninja? Excellent. Did you enjoy yourself? I sure did as well. Thank you very much for your time and attention. I really appreciate it.